The long journey of an electron. What I'm about to tell you is key to deeply understanding the contents of the Metabolic Orchestra series. I found these cycles the most challenging to learn about, yet also the most fascinating and important. They describe how molecules from the food we eat are broken down to release electrons and protons, the raw currency of energy in your body, and how that potential is carefully captured and directed to power every cell. Deep inside every one of your cells is a place that never sleeps. It doesn't glow, it doesn't make noise, but it is always moving. This place is the mitochondrion. Most people imagine mitochondria as tiny furnaces that burn calories. That image is comforting, but mitochondria don't burn food. They guide electrons. Every meal you eat, whether it's bread, olive oil, or salmon, is quietly dismantled elsewhere in the cell. Carbons are stripped away. Bonds are loosened. What finally arrives at the mitochondrion is not food, but potential energetic electrons bound to NADH and FADH2, or as acetyl-CoA carbon skeletons that will generate electrons in the Krebs cycle. Electrons are powerful. Left uncontrolled, they damage everything they touch. So the cell gives them chauffeurs. Two of them. One is called NADH. The other is called FADH2. They don't carry calories, they carry potential. Inside the mitochondrion is a circular path, like a roundabout in an old city. This is the Krebs cycle. Nothing enters it casually. At the gate stands a 4-carbon molecule named oxaloacetate, waiting. It is never consumed. It is the keeper of the cycle. When a 2-carbon fragment called acetyl-CoA arrives, born from sugar, fat, or protein, oxaloacetate embraces it. The moment they join, a new molecule is born. Citrate. Citrate is the opening chord of the cycle. It is the signal that energy production has begun. Citrate does not rush, it does not explode. Instead, it moves calmly through a series of transformations. At each step, pieces are rearranged, bonds are reshaped, and, most importantly, electrons are gently removed. Those electrons don't fall into chaos, they are caught. 3 times they are handed to NAD+, which becomes NADH, swollen with energy and eager to move on. Once they are handed to FAD, becoming FADH2, a quieter carrier, but no less important. By the time the Krebs cycle completes its function of extracting high-energy electrons, the original acetyl fragment has vanished into carbon dioxide. Nothing tangible remains, except the electrons, and they are everything. NADH and FADH2 now travel to the inner wall of the mitochondrion, a folded membrane packed with machinery. This is where the real work begins. Here stands the Electron Transport Chain. Electrons step from one massive protein complex to the next, moving downhill in energy. They never jump freely. They are passed hand to hand, iron to copper, molecule to molecule. With each step, something subtle happens. Protons are pushed, gaining potential energy at complexes 1, 3, and 4 of the Electron Transport Chain They are pushed out of the mitochondrial matrix, building pressure. Not heat, not fire. Very high potential energy. A difference in charge. A difference in concentration. This growing imbalance is life's battery. ATP has not been made yet, and that's important. Energy has not been spent. It has been stored as electrical potential. And then comes the moment everything has been preparing for. Protons want to go home. There is only one way back. They pour through a structure embedded in the inner mitochondrial membrane to the next protein complex. Complex 5, ATP Synthase. It does not look dramatic, but it is one of the most astonishing machines biology has ever built. A spinning turbine. As protons power the turbine to spin, the enzyme spins. Each proton passage advances rotation. Not metaphorically. Physically spins in a turbine. That rotation forces ADP and phosphate together, locking them into ATP, a molecule that can now leave the mitochondrion and power muscles, thoughts, heartbeats, and healing. This entire process is made up of the 3 interconnected systems we've just described. The Krebs cycle, also known as the Citrate Cycle, the Electron Transport Chain, and the ATP synthase process where oxidative phosphorylation occurs. To fully understand the series I'm presenting, it's important to have a good grasp of how they work together. I have done my best to describe accurately how these systems collaborate to create the energy that powers your body. Feel free to listen several times. It's a lot to absorb.